Number 1 asks us to define the following terms in our own words. So the first one is an included side. So this is a side that is between two angles. So we're just going to draw a picture kind of to help with this one. But so if we just have a triangle and then we have two angles marked on this triangle. So maybe this angle and this angle marked. Then the included side is the side that's between those two angles, or the side that connects kind of those two angles. So this would be our included side. For an included angle, it's an angle that is between two sides. So again, if we had a triangle here, and let's not do red. All right, so then if we had a triangle drawn and we had two of the sides that were marked. So if this side was marked and this side was marked, then the included angle there is the angle between those two sides, okay, or like made up of those two sides. So those two sides are creating that angle. So that would be your included angle. Coincide. So coincide just means that, I don't know, and in your own words, I just think of if a figure is going to coincide or a point is going to coincide with other, it's going to land on top of it. So lands on top of. So when we're talking about translating, reflecting, rotating, and moving points so that they coincide, it means they're going to land on top of that other one, or land on top of, maybe we can even put in here, each other. Parallelogram is just a four-sided shape with two sets of parallel sides. A congruent statement is a statement that tells you which figures are congruent, and it lines up the corresponding parts. So for example, a congruent statement might look something like this. Triangle ABC is congruent to triangle DEF. And then you would know that point A coincides with D, or would be the corresponding point to D. B and E would go together, and C and F would be corresponding. Then finally, isosceles. So isosceles is just a triangle with two congruent or equal sides. All right, number 2 says, given the following figures, determine the measures of the angles that are asked for and explain how you know. So we're given that this one is 76, and this one, it should probably tell us that this is a parallelogram. So this should have said that we have a parallelogram here. And in the case that it's a parallelogram, then we know that the angles next to one another are going to be supplementary. So this angle here and this angle here, since we've got parallel lines here, okay, and then if we think about rotating this up, it'd be next to it, and that's going to be 180 degrees. So we would do 180 minus 76, and that's going to give us 104 degrees for B, and then also for D. If we did a similar line of thinking of these two lines being parallel and this being the transversal, would make those two supplementary as well. Then B gives us that angle L is 35. So we see that it's isosceles. So we see that these two sides are equal. That means that this angle is also going to be 35 degrees since it's an isosceles triangle and the base angles are equal. And then for J, you're going to want to subtract those two angles from 180 since we know the total of the angles in a triangle is 180. So that's 70. So 180 minus 70 gives us 110 for this one. And that's for using triangle sum theorem. Part C, angle X is 94 degrees. Angle ZWX, so this whole angle right here is 112. And then it wants us to find angle Z, which is here. Let me do a different color. So angle Z, and then also ZYX, so this big angle. So those are the two angles we're looking for. So since we see that these two sides here are the same and then that they share this middle line, we can see that we'd be able to reflect it on top of the other one. So this 94 is going to be the same as angle Z. So this one's going to be 94 degrees as well, because we can see that this is a line of reflection. And then this green angle here, we know that all the angles in a quadrilateral total 360. So we could subtract 94, 112, and then the other 94. And that would leave us with 60 degrees. You may also have used triangle sum theorem for that. So if you looked at the fact that you know that this 112 is getting cut in half. So if you cut that in half, you'd have 56 here. And you know this one is 94. So you could be looking at this as a triangle totaling 180. So you also could have done 180 minus 56 minus 94, which would have gotten you 30 degrees here. And then you'd have known this other piece over here is 30 as well. All right, number 3 says, show the following triangles are congruent through rigid motions and through triangle congruence. So you kind of have had two ways that you've been looking at this in this chapter. And then just be sure to justify your reasoning for each method. So you probably feel more comfortable with one than the other, which is okay. But I am going to do both methods here. So explain using rigid motions. So remember, rigid motions is where we're going to be using reflections, rotations, and translations to show that all of the points coincide with the others. So the first thing that we're going to do is reflect triangle WXY over line segment WY. So if we take a look here, here's line segment WY. So we're reflecting WXY over this line. And then you have to say how you know that they will, all of the vertices will coincide with these other ones to prove that it's congruent. So we know W will coincide with W, and Y will coincide with Y since they are on the line of reflection. So they won't move. So now we've proven or justified that W lands on itself and that Y lands on itself. So now we just have to give a justification as to how we know X will end up coinciding with Z. So X will coincide with Z since X and Z are the same distance from points W and Y. So let me move this up a little bit here. So since we see that X is this far, let me change the color here. So we know that X is this far from W and Z is that far from W. Okay, X is also this far from Y and Z is that far from Y. Okay, and lines can only intersect at one point. So if we have this, they'd have to intersect on Z since they're the same distance from W and Y. All right, then using triangle congruent, so this is like your side, angle, side, angle, side, side type stuff. So let me delete this out of here. So how would we prove it using triangle congruence? So we would say that segment XW is congruent to ZW, and XY is congruent to ZY, because that was given to us on the diagram. So we see over here on the diagram that they told us these segments were equal and these segments are equal, so we're going to get that in our proof. And then I just want to get some of these markings in here. So we've got this congruent to this segment congruent to this one. So that gives us two sets of sides that are equal. Okay, whoops. So then we also know that WY is congruent to WY because it's the same segment. So therefore, the two triangles are congruent. So triangle XWY is congruent to triangle ZWY by side congruence theorem. So we prove those two sets of sides, and then we know this segment is equal to itself because it's in both triangles. And so that's what we have here. And then that proves that these two triangles are congruent to each other. Whoops, congruent to each other by side. Then this last one says, now that we've proven that the triangles are congruent, how do we know that angle X, so this angle here, is congruent to angle Z? Remember, we did two separate problems. Okay, so we did this two separate types of ways. So if you did the reflection way, then you know that they're images of each other. So the fact that they're images of each other makes them congruent. So for this side, now that we know the triangles are congruent through rigid motions, we know that angle X is equal to angle Z because they are images of each other. So that would be for this side. And then when you prove that the triangles are congruent through triangle congruence, okay, then we know, since we know the triangles are equal or congruent, we know angle X is congruent to angle Z since they are corresponding parts. So since the triangles are congruent, okay, then their corresponding parts are also congruent. All right, number 4, given the pairs of triangles below, add some markings for the angles to make them demonstrate each triangle congruence. So if we did side, we would want to make sure that we had all the sets of sides with markings on them. So this would be that those two are congruent by side. For side, angle side, pick what angle you want to use. So if you're going to use this angle, that's fine. Then you'd need to have the sides on either side of that angle. So this one and this one, and this one and this one. You need to make sure that angle ends up between those two sides. And then angle, side, angle. So if you pick a side, so if I want to use this as my side, then I just need to make sure I have the angle on either side of it. So if I want to do this angle and this angle then. So this one is corresponding to that, and this one here, so this would be angle, side, angle. And you can have picked different sides, just have to make sure you have the correct part included. Number 5, given the parallelogram below, state how you would know each statement is true. So based on this, so how would we know that EF is congruent to GH? So here's EF. How do we know that that's congruent to GH? And that's because we've got opposite sides of a parallelogram. are equal. Okay, so those are opposite sides in a parallelogram, so they're going to be equal to each other. How do we know that angle FHG, so FHG, so this angle here is congruent to HFE, so this little angle here. So we're looking at these two angles. So how do we know those two angles are equal? Well, we know that these lines here are parallel, so these are alternate interior angles. So we know that when we rotated on parallel lines, okay, these angles, if you rotated kind of between the middle of these, this would rotate onto the other one, and that gave us alternate interior angles that are equal. How do we know HE is parallel to GF? So those are opposite sides. So that's through the definition of a parallelogram, that opposite sides are parallel. You could write the symbol for parallel, or you could write out the word parallel. And then finally, how do we know that angle HEK, so HEK, this one, is equal to KGF, this one? So again, when we look at this angle is made here, this one's made here. We know that these two sides are parallel, so those are going to be alternate interior angles again when we look at it this way. All right, number 6, write a sequence of rigid motions that takes figure ABC to KLM in each of the diagrams. So you're just going to fill in the blank. So most of it is here for you. So we want to translate point A. So here's A, here's B, and here's C. So we want to, they're saying translate point A to what? Well, we need to take A to K. So translate point A to point K by the directed line segment AK. So the one that would connect A to K, telling us to go this direction. Okay, so we would move this whole thing, translate A to K. Then it says, then rotate around point K. So we've already got them on top of each other. So rotate around point K until B coincides with what? So what is B supposed to rotate down onto? So B is supposed to rotate down onto L. So we're going to rotate, keeping A and K on top of each other until B lands on L. We know that point C will then land on M. So it's going to land on M because C and M, so C and M, are the same angle. So we know they have the same angle. We can see that here to here. Okay, so I have the same angle and they're the same distance from L. So from this point that was right here. So they have to land on each other. Okay, so we've got the same angle and then it's the same distance up that ray. So then write your own sequence of rigid motions that will take this triangle over to this one. So we can use this as our outline if we wanted to. So we're going to translate point A to point, so which one does A go with over here, which is K. So translate point A to point K by directed segment AK. Then rotate. Okay, so now we've got A on top of K, so now we're going to want to rotate. Okay, then rotate ABC until C lands on M. Okay, so until point C coincides with or lands on point M. Then we know that B will land on or coincide with point L because they are the same angle and distance from M. And actually, I think I did that backwards because we should have got these angles together. So actually here, so we should rotate until point B lands on point L, so that we get the two angles that are the same size. Then we know C will land on M because they're the same distance and angle from L. All right, then number 7 just has us looking at these different sequences to see which one will take A, B, C onto D, E, F. So make sure that you're recognizing that they give you that we should be taking D, E, F to B, A, C. So they're telling us what stuff needs to land on what. So D needs to land on B, E needs to land on A, F needs to land on C. So translate triangle DEF using directed line segment EA. So this is putting E onto A, so that's good. Okay, so they had us move E onto A. Whoops, onto A. Then it says rotate around point A, which is what we got together, so that's good, until D coincides with C. So they said D coincides with C. That's not what we want. We want D to coincide with B. So this is bad. So A is wrong. Next one starts out the same. It says directed line segment EA. So that's good. And if we look, that's in all of these. Directed line segment EA, directed line segment EA. So that's the first step in everything. Now this says rotate around point A, which again is good, until D coincides with C. D coincides with C, not what we want. Okay, so that's bad again. So this one, E to A, rotate around point A until D coincides with B. That is what we want. Okay, so we want to rotate this triangle until D lands on B. And then it says reflect across line AC. Here's the line we're reflecting across. That's not what we want. Okay, we want to reflect across this line where they're touching. Okay, so we wanted to reflect across AB, so the correct answer is D.